math, numbers,
sine wave,
coordinates,
radius,
let's factor more,
polynomials,
numerator.
equations.
As we trek through this gorgeous wilderness of mathematics, we find ourselves at a river that we need to cross before moving onward to the rest of this beautiful scenery, and that river is called algebra. The key to crossing the river of algebra is to slowly build a bridge, one stone at a time. Lucky for us, we have a friend who is here to help us. That friend's name is Algebra Tiles. We will be working with both variables and constants today. Variables are the unknown, that which we cannot see. The first thing you need to know is that there are two different kinds of algebra tiles, an X, which is the long skinny bar, and a 1, which is the little square. Both of those have a positive side and a negative side, the negative being shown by red. The first example we're going to look at is the equation x plus 4 equal to 6. We're going to set that up with one x bar and 4 ones, and then put an equal sign in the middle, and then 6 on the other side. Now let's think about what it is we're trying to do here. We're trying to solve for x, which means our final answer will have x equal to a number, and we want x by itself on that left side. Currently, x is not by itself on the left side, so we're going to use some inverse operations to get it that way. What I mean by inverse is opposite. So when you have a positive tile and you want to get rid of it, you'll introduce its inverse, which is a negative tile. This creates what's known as a zero pair. A helpful way to think about equality is a scale that's in balance. So the weight of one side is going to be equal to the weight of the other side. Therefore, if we take one thing off of one side, we need to take that same amount off of the other side. If we add something to one side, we're going to need to add that same amount to the second side in order to keep that scale balanced. In my problem, on the left side I have an x bar, which I want by itself, and currently there are 4 little yellow tiles alongside it. So to cancel out those 4 yellow tiles, I'm going to introduce 4 red tiles, and each of those creates a zero pair and then gets rid of those 4 tiles, leaving me with just the x bar on the left. However, in order to keep this equation balanced, I need to also add 4 red tiles to the right side. And after I've done all of my canceling out, done my zero pairs, taken everything extraneous off the board, I'm left with my final answer, x equals 2. Alright, one more example here. We're looking at x minus 3 equals 1. This time there are 3 negatives on the left side with x. To cancel out those 3 negatives, we're going to add 3 positives. We need to do the same thing on both sides. On the left side, x is now by itself, which is what we wanted. On the right side, nothing cancels. There are no zero pairs because there are only positive tiles, and when we count those, we see that x equals 4. We have successfully built the first few stones across the bridge of algebra. It is up to you, my friend, to continue building that bridge until we've made it all the way across the river. Good luck, and I will check on you soon.